If you're at all interested in the events at the end of the Pleistocene epoch, you've heard of the transitional period referred to as the Younger Dryas, which is named after the flower Dryas octopetala that you see an image of behind me. Then there's Meltwater Pulse 1b, the lesser referred to Meltwater Pulse 1a, and a few other events that happened in the same time frame. Geologically speaking, that is. But where do they all fit in together? How do they relate to one another? That is what I hope to show in this video. I want to place them all together relatively, so at the end I hope you'll have a better grasp of what is what and when is when. Hi, I'm Greg, and welcome to What's Old is New Again. Let's look at some of the major events of this time frame. First is the Bowling-Alarod warming period, which at first seemed like just the next one in a series of regular warming cycles. But there was this sudden influx of water called Meltwater Pulse 1a, which coincides rather closely with the start of the Bowling-Alarod warming, which caused ocean levels to rise about 60 feet. Then there was Meltwater Pulse 1b, which was shown to happen some decades after the defined end of the Younger Dryas. This caused global ocean levels to rise an additional 13 feet. So we have a couple of things to consider here. First, how long did it take the oceans to rise during each pulse? Under a year? A few hundred years? In short, the gradually curved but ever-increasing line you see here is a best guess. We need more data and better accuracy. But there may have been more of a step effect in places, with sharper rises and flatter areas than shown here. Oceans were gradually rising all along, not just during the pulses. But to what extent? What triggered these rises? A bolide impact on an ice sheet, melting and vaporizing a good chunk of it? Was it the outbursting of a glacial lake and the subsequent outpouring of its waters into the ocean? What of the climactic consequences of the meltwater? A temporary shutting down of the Gulf Stream and its potential freezing effects is one of the things that has been discussed at length. It's important to note that none of these dates discussed can be considered exact. As time goes by and science progresses, our black and white tube TV with rabbit ears picture of the past will slowly give way to a view akin to HD TV with 4K color. I've just mentioned uncertainty and duration with the meltwater pulses. There is also ambiguity with actual dates. This applies to pinpointing a relatively instantaneous event like a coronal mass ejection, volcanic explosion, extraterrestrial impact, or glacial outburst flood. We're taking our best guess based upon sampling data that is blurry. For instance, there is one instant rather than gradual event that we know about. The event took only a minute, and it may have been narrowed down to a date, and that is the Burckle impact you see here on the right in purple. The Burckle impact happened 4,500 to 5,000 years ago or longer. That's why I have those fan-outs at the top and bottom of the purple bar. The event could have been anywhere in that range. I mean, how would you get an exact date on a crater at the bottom of the ocean? Notice there is no climatological shift associated with the event. This is where the impact crater is located, under 12,500 feet of water off the coast of Madagascar in the Indian Ocean. That's comfortably over 2 miles deep. One of the lasting effects of the impacts was these massive chevrons shown on the islands of Madagascar and as far away as Australia. Now let's get back to the question I posed on dating it. It wasn't entirely rhetorical. One way is carbon dating the marine shells found in the associated chevrons. Another is carbon dating the remains of tiny sea creatures found in association with magnetic microspherules in the deep sea sediment cores. A third way was an analysis performed by Bruce Massey and Dallas Abbott of 175 flood myths, dating them and tying them to an astronomical event on May 10th, 2807 BC, which could have been the impact. Thinking of the flood myths, we know this event caused great tsunamis, but think of the heat and spray of the impact and the amount of water thrown up and vaporized. This likely would have caused global rainstorms as it precipitated back over the earth over the course of, 40 days and 40 nights? This would have led to massive localized flooding until the status quo could have been recovered. Yes, I think this is the impact that is a strong candidate for the source of Noah's flood. Looking into other events of import in the time frame, we have the black mat shown here in this photograph by Alan West. This is a carbon-rich layer that has been identified at dozens of sites and dates to the same time frame as the onset of the Younger Dryas. This layer contains several impact proxies such as magnetic microspherules, nanodiamonds, platinum and iridium spikes, silica-rich melt glass, and others. The presence of all these materials leads credence to the idea that the Younger Dryas may have been triggered by an extraterrestrial impact. You certainly cannot talk about the end of the Pleistocene without mentioning the megafauna extinction, the die-off of approximately 177 species of large mammals weighing an average of 100 pounds or more, which included 35 entire genera in North America alone. This is Randall Carlson's mortality chart, which graphs the frequency or body count of animals found against the age of the fossil remains. Traditionally, discussion of this die-off centered around the overkill versus overchill hypotheses. Were they hunted to extinction, or were they done in by climate change? With the advent of the Younger Dryas impact hypothesis, we have a third option to consider. Superimposing some of the critical climactic events, it seems more likely that it may be a 1, 2, 3 punch that they couldn't recover from. Tying it all together was the goal of this video, with the hopeful outcome of narrowing everything down to a couple of events. Unfortunately, the timing of the events is too spaced out to attribute several events to the same cause. There could be up to 5 separate catastrophic events that were independent of each other. The black mat coincides nicely with the onset of the Younger Dryas, but what else could be paired together? Could the onset of the Bowling Alarod have triggered Meltwater Pulse 1A that happened 100 years later? You could ask the same question about the end of the Younger Dryas and Meltwater Pulse 1B, but that is more of a stretch time-wise. I haven't even mentioned the creation of the Carolina Bays, which I believe are secondary impacts from a primary impact on the glacial ice sheet. I don't include them because they haven't been dated conclusively. There is discussion as to when they were created, and there is evidence that they are older than the time frame we're looking at here. For all the information on the Carolina Bays you could possibly want, check out Chris Cottrell's channel, Dabbler's Den. One other thing I want to touch on is the Y chromosome bottleneck, which was a collapse in male biodiversity that happened between 7,000 and 5,000 years ago. I believe this was related to warfare rather than environmental causes. It may have been the war from the Mahabharata. If you want to learn more about this, I highly recommend you look into the work of Nilesh Oak. So there you have it. There was clearly a lot going on the planet in the last 15,000 years or so. Being able to tie one event to another could reduce the number of causative catastrophes, but more work needs to be done to actually tie them together. It would require us to be able to better focus the lens on our camera into the past. As I mentioned, we may have had up to 5 major events, which means one every 3,000 years on average, which is extremely frequent geologically speaking. But that's just the last 15,000 years. What about the 15,000 before that? Was it quieter or worse? The farther back in time we go, the more challenging it is to gather data and assign dates. One thing is clear, however. Not only has Earth's past been far more violent than we expected, we just might be overdue for the next event. Thank you.